Hi students, welcome back. Today we are here to start with parametric differentiation, the last of the type of differentiation. Here again I would like to mention that this is very important for JEE Advanced. Initially it would appear very easy, but the straightforward it looks, it isn't. We have to figure out where we can make the parameters, and from those how we can get the results using differentiation. Again, it's more of practice kind of thing. The conceptually it will look very easy, but based on that questions are coming in JEE Advanced. So we must be very careful about this. We must not take this lightly, as it is very important concept. Again, a small concept but important one. Let's begin with the part. Starting with the parametric differentiation. Okay, so let us first see what the parameter is. Okay, now those who must have studied straight lines or maybe some other chapters, they must have been studied something like parameter. Okay, so basically in differentiation also the same concept will apply. Okay, so if I am saying like I have two variables x and y which are not directly dependent, but they are dependent on a third variable. So can I find the differentiation of first variable with respect to second? Let's see what the scenario is. Okay, now suppose there is a person A, okay, who runs faster than B, and there is a person C who runs slower than C. So is there any way which I can compare A and C? The answer is yes. Okay, so if I measure the rate of change of A with respect to B, suppose if I say quantitatively that 5 km per hour is the speed which A exceeds B and C is slower by 3 km per hour. So I can effectively say that A is 8 km faster than C. The same scenario goes with the differentiation. What we are going to do, if suppose X is dependent on T and Y is dependent on T with some other relation. So I'm going to first look at the change that X experiences as I change T. So that will be basically dx by dt, which will be f dash t, and from here I will be getting dy by dt, which is equal to g dash t. From this I can get dy by dx or dx by dy, depending on the question requirement. Okay, so in order to find the differentiation, we have a chain rule. Okay, we have it by chain rule. Okay, so chain rule, again it says that it's similar to that thing. If I can express this thing, so what I am saying is that y is f of t and x is basically g of t in this question. Okay, so you can yourself take an example, or maybe if I give an example, x is equal to cos t, y is equal to sin t. Okay, so in this obviously x and y are not directly related, but if someone wishes, he or she can express it as maybe 1 minus sin square t, and then you can write it as 1 minus y square, like this. You can express like this. Okay, or you can square it, add it, and get x square plus y square equal to 1, maybe like this. Okay, so different options are there, whether you go for this or you can get the differentiation from this itself. Okay, so it totally depends on how you want to proceed. Okay, let us look at an example. This will become more clear. It's nothing but the chain rule, product rule, which we have done, implicit function, a combination of that. Okay, don't get confused by the different terms which we are doing. Everything is just following one basic thing, that we want to note the change of one variable with respect to the other variable. Let's have a question for this. It says a is equal to this, then dy by dx. Okay, is okay. Now again same way I'll go. Dx by dt I'll find by that rule. So 3a cos square t. By now I guess you must be comfortable with this. So this is basically, first we will follow the power rule, then we will differentiate this thing. So cos t will give me minus sin t. My dy by dt will be 3a sin square t and cos t. To find dy by dx Okay, what I'll do, I'll just write this one on the numerator, 3a sine square t cos t over minus 3a cos square t over sine t. So this gets cancelled, cos with cos, sine with sine, this reduces to minus tan t. Now the interesting point to note is that it is in terms of t, okay? It is in terms of, so for a given point, suppose if I want to know that at t equal to 1, okay, so I'm directly getting that derivative in terms of t. Obviously, if we were to find x and y, obviously we would have needed a t point, okay? Or if x is given, we can find t accordingly, okay? So parametric differentiation, as I've said, that it's very easy, okay, but it's very, very important. Like once the things become a bit complex, when you have to take variables, like in conic sections, you must have done this in great detail, okay. So once you are taking parametric forms and finding the change in variables, the calculations becomes quite easier. If you have any doubt in this topic, you can post it for free on AskIITian website. For this, just visit the askIITian.com, and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category post your question and click the Get Answer button. Experts at AskIITian will answer your query within 24 to 48 hours. So this was easy indeed, okay. Here we have learnt different type of, till this part we have learned different types of differentiation, okay. Now we are from the next part, that is the concluding phase of our journey in terms of concepts. We are going to apply all the things which we have learned together as a fusion. So till now whatever we have learned, it must be thoroughly revised, or you must be very much clear about the things which we have done till now. In the next part again, that is miscellaneous, the concepts straightforward related to JEE questions will be discussed. There is no as such concept involved, but the things which will be discussed, they will be majorly taking the directly the questions which are coming in the JEE Advanced or JEE Mains, and even for maybe 1 or 2 tips for CBSE also. So stay tuned for the coming part.